Two bills leave the cash cassette at the exact same time. They are moving fast, faster than you can blink, as they ride on a stream of air through a tight channel. Before those bills move even a little farther, the machine already knows something is wrong. No person is watching the process, and there isn't a regular camera checking the work. Instead, a pressure sensor feels that the air gap is just a tiny bit too thick. In less than a millisecond, the transport stops so the bills can be sent into a reject bin. You never see them, and you never even know they were there. So how does a machine moving money that fast catch a mistake that small every single time? To see how it works, we need to look inside the hidden logic of the machine. Most people think of an ATM like a vending machine, where you put in your card, tap a few buttons, and money comes out. It sounds simple, but once we look inside that steel box, that idea falls apart. What we really have here is a fast bill sorting lab. The machine has to do very careful work because paper money is actually quite hard to handle. Early machines in the 1960s and 70s used simple friction rollers, which meant a rubber wheel pressed on the top bill to try and peel off one sheet at a time. It worked, but only just. The problem was the machine could not really tell if it grabbed one bill or two. It also had no way to know if a bill was worn out or even the wrong type, so it just pulled the paper and sent it forward. That was less of a problem when these machines were new and people watched them more closely. But as more machines showed up in the world, those weak points started to matter a lot more. The thing is, cash is not neat and perfect. Bills stick together from static, they get bent, and they wear down over time. Some are thick, while others are thin, and a simple roller treats every bill the same way. To solve this, engineers had to think backwards. Instead of squeezing the bills harder, they built a system that could feel what it was touching and react right away. That brings us to the core mechanism, where the machine moved away from pure friction and toward vacuum-assisted handling. Inside the machine, bills sit in a spring-loaded cassette that keeps the top bill in the right spot all the time. The machine has to grab one bill, check it, and move it out of the way before the next cycle starts. The clever part is how the picker does that first grab. The note picker is the very first part of the mechanism to touch the cash. To grab the top bill from the cassette stack, the machine uses either suction cups or friction wheels. While both work, vacuum systems are the more advanced version, and the logic inside is actually quite simple once we strip away the outer casing. Think of what happens when you press your finger flat on a sheet of paper and lift it up quickly. Sometimes the paper sticks and comes up with your hand even though you aren't pinching the edges at all. This happens because the air pressure under the paper is stronger than the pressure in that tiny sealed space between your skin and the page. That small difference in pressure is doing all the heavy lifting. In simple terms, the picker does the exact same thing, but it does it in a controlled way at incredibly high speeds. To make this work, a vacuum pump creates negative pressure and sends it through small air channels to suction points on a rotating part. Some systems use suction bars mounted on rotating discs to lift one note at a time. When that part makes contact with the top bill, the low pressure holds the note firmly and pulls it away from the stack. Because the pull is spread across the surface of the paper, the machine doesn't have to rely on a physical grip at the edge. This helps a lot when the machine has to handle bills that are worn out or slightly damp. But there is a problem that engineers had to solve. Bills have a tendency to cling together because of static, moisture, or just the texture of old, rough paper. When the picker lifts the top bill, a second bill might try to come along for the ride. In the industry, we call that a double pick. This is where it gets clever. Right after the picker, the bill reaches a component called the separator. The separator is designed to add drag to the second note, while a stream of air helps peel the first note away. If the machine senses that the air gap is too thick, it knows that two bills are trying to pass through instead of one. A pressure transducer turns that physical change into an electrical signal, allowing the machine to count, compare, and react almost instantly. If you like seeing the hidden logic inside everyday machines, hit subscribe. We break down how the parts work, step by step. Now the bill is moving through the system. It was picked cleanly, pulled away from the stack, and sent through the transport path on a controlled stream of air. But moving the bill is only half the job, because the machine still has to decide if that piece of paper is real, safe, and good enough to hand to you. This is where the sensor gate comes in. Every bill in a modern machine passes through several different sensor checks before it ever gets near the cash slot. We aren't talking about just one check, but a whole stack of them working in sync. No single sensor can catch every possible problem by itself, so the machine uses layers of security to be sure. The first layer uses visible light. Contact image sensors capture a full, high-resolution image of the bill in a single pass. They aren't just reading a barcode. They are comparing the size, the printed pattern, and the small picture details to a known master pattern. If the dimensions are wrong, or the print looks slightly off, the bill gets flagged immediately. The second layer uses ultraviolet light to look for things the human eye can't see. Real banknotes often have glowing security threads or special ink that reacts in a very specific way under UV light. A fake bill might show nothing at all, or the ink might glow in the wrong place. The machine is essentially asking a simple question: does this bill react the way a real one should? The third layer uses infrared light to look even deeper. Real banknote ink is designed to absorb and reflect infrared light in a very specific pattern that a home printer just can't replicate. Even if a fake looks perfect to your eyes, the infrared light will expose the different chemical makeup of the ink. The fourth layer uses magnetic sensing. Some parts of real currency have a magnetic signature built directly into the printed design. The machine reads this signature while the bill moves past, providing one more way to verify that the bill is exactly what it claims to be. And then there is one more job to do, which is fitness classification. This is just a fancy way of saying the machine grades the physical condition of the money. If a bill is too torn, too dirty, or just too worn out, it gets sent to the reject bin instead of being handed to you. In machines that handle deposits and recycling, this matters a lot because the system has to decide if a note is good enough to store and use again, or if it needs to be pulled out of service. This is exactly what caught the double pick we talked about earlier. It wasn't a person or a normal camera that caught the error, but a sensor that noticed the gap and pressure didn't match a single bill. One reading led to one fast decision, and the bill was diverted. Every note you get from a machine has gone through that entire chain of picking, separating, and scanning in less time than it takes you to blink. An ATM is much more than just a locked box full of money. It is actually a high-precision lab that checks every single bill it touches all day long. What looks like a simple transaction from the outside is really a complex chain of mechanical parts, air control, and sensor decisions working in perfect sync. The clever part is how the design keeps changing. Modern cash recycling machines can run this entire process in reverse. They take in the bills you deposit, scan them for authenticity, and grade their physical condition to decide if those notes are clean enough to give to the next person. This means the same machine giving you cash is also judging whether your money is fit to stay in the system. The transaction you finish in just a few seconds took decades of engineering to become this fast and this reliable. That is the hidden logic behind every cash withdrawal you make. If you want to see more of how the world works, hit subscribe. We take apart the machines you use every day and show you what is really going on inside. Thanks for watching, and I will see you in the next breakdown.